Come on, get in here.
Hey, John, what are you up to?
Well, I'm trying to install this new hard drive I got, David.
Looks to me like you could use some advice.
Yeah, I really need some expert help.
Expert help? I've got just what you need. It's a video from Telegraphics International. Let's take a look at it.
Welcome to Amiga Hard Drives, the complete guide. During the course of this instructional videotape, we will show you the hard drive capabilities of the Amiga computer, teach you how to install, partition, and format your hard drive, explain hard drive directory setup, outline several methods you can use for reliable backups, and finally, describe hard drive options available to bridgeboard owners. As you know, there are many different disk controllers available for the Amiga. This tape will address features common to all these boards, but will cover in specific detail two of the most popular: the GVP's 40 meg hard card with 2 megabytes of RAM, and the Commodore A2091. Before installing your hard drive and controller, we recommend that you view this tape in its entirety. Also, if you wish to follow along with a copy of the script, it may be printed from the utility disc that comes with this tape. The subject matter is oriented primarily towards the Amiga 2000 series of microcomputer. Amiga 500 and 1000 owners must use external hard drives that attach to an extended bus connector, but the basic concepts will apply to them as well. A hard disk is essential to change the Amiga from a capable microcomputer into a sophisticated and powerful workstation. Data access and data transfer will be 4 to 5 times faster than with floppies, while the fast file system, which only hard disks use, increases transfer speeds even more. A hard drive can store the equivalent of 100 or more floppies online with instant access. Furthermore, a hard drive is the only way to handle files that are larger than 880 kilobytes. Many tedious tasks become much easier once a hard drive is set up properly, and this allows the user to concentrate on the more creative aspects of his work. Hard drives for the Amiga come in two sizes, 3.5 and 5.25 inches. In each of these sizes, the capacities range from 10 megabytes to over 100 megabytes. The physical dimension, not the capacity, is what is important for the Amiga. A 5.25 inch hard drive can be installed in only one location, the 5.25 inch bay. If you now have, or ever plan to use, a bridge board, this larger bay will be used by a 5.25 inch floppy and unavailable for a hard drive. On the other hand, a 3.5 inch hard drive can be mounted in one of three places: in a 3.5 inch bay, in the 5.25 inch bay, or on the controller card. This hard card arrangement gives you more flexibility in adding internally mounted peripherals and will not interfere with the bridgeboard floppy. To handle the data flow to the hard drive, there are two types of controller boards available for the Amiga. The SCSI, which stands for Small Computer System Interface, is pronounced SCSI, and the ST506. The ST506 has been around a long time and is the one most commonly used by IBM PCs and compatibles, and can support a maximum of 2 hard drives. SCSI controllers are newer technology, transfer data faster, and can support up to 7 SCSI-compatible devices, which do not necessarily have to be hard drives. One advantage of the ST506 controller is that it is slightly less expensive. Whatever board you choose, be sure that it supports auto-configuring and auto-booting. An auto-configuring board relieves the user from having to run a separate configuration program each time the Amiga is booted up. Almost all of the current controller boards support auto-configuring, as long as you're using Amiga DOS 1.2 or higher. While an auto-configuring board is desirable, an auto-booting board is nearly mandatory. Auto-booting means no floppy is needed to start up the Amiga. It boots very quickly from the hard drive. Auto-booting is supported by most controllers, but it requires Amiga DOS version 1.3 or higher, and version 1.3 of the Kickstart ROM chip installed on your motherboard. The method of data transfer used by the controller board also affects performance. The Amiga can support data transfer by direct memory access, called DMA, which means that after the CPU chip sets up the transfer parameters, a coprocessor chip quickly takes over and actually moves the data. While this transfer is in progress, the CPU can resume running other applications. Controller boards that do not support DMA require that the CPU must move all the data. This increases CPU workload and makes your software appear to run slower. So after all this discussion, what is the bottom line recommendation? For future flexibility, you should get an auto-booting SCSI controller board. It is desirable that the drive be mounted on the controller board. This will free up the floppy drive bays. DMA data transfer is another feature that you should rank high on your list. You should get a 3.5-inch hard drive of at least 40 megabytes capacity, or even higher if you do a lot of graphics work. And if you have not yet installed the 1.3 ROM chip, you should do so to take advantage of the auto-booting capability. Now that we've seen what kinds of hard drives the Amiga can use, as well as where they can be mounted, let's look at some of the physical and logical characteristics of these devices. You must understand these concepts to properly configure your hard drive. A hard drive contains hard metallic disks, often 3 or more, upon which the magnetic media is coated. There are usually 2 read-write heads for each hard disk or platter, one for the top side and one for the bottom. Because the media is rigid, the heads can be positioned much closer to the platters than the heads for a floppy disk. The data, therefore, can be encoded much more densely. Where a floppy has only 80 concentric data tracks on its surface, a 3.5-inch hard disk may have over 600. The circular track is further subdivided into sectors, usually 20 or more, while the floppy has only 11. Again, this means more data per track for the hard drive. A sector always contains a block, or 512 bytes of data, on both the hard drive and the floppy. The concept of cylinders is a convenient method of grouping tracks. It is the result of the vertically positioned read-write heads at the end of an equal-length arm assembly. As this assembly moves within the stack of platters, the heads are always accessing a vertical stack of tracks. When viewed from the side, this stack of tracks forms a cylinder. A group of contiguous cylinders makes up a partition, which is treated as a discrete logical entity. In other words, each partition on a single physical drive appears as a separate logical drive to Amiga DOS. Partitions are a handy way of separating parts of your hard drive that may have different kinds of characteristics, such as different types of data, or even different operating systems. The Commodore 2090A controller, for example, requires 2 partitions, one with an old file system to boot from, and one with a fast file system for fast data access. Those of you who use a bridge board may have a partition reserved for use by it, with another partition reserved for the Amiga. You can have as many as 8 partitions under Amiga DOS, but remember that each partition requires a certain amount of chip RAM to be allocated for data transfer buffers. Most users find that 2 or 3 partitions are sufficient for their purposes without using too much chip RAM. The relative sizes of these partitions will vary, depending upon the amount of data to be stored in each. In our example, we are using a 40 megabyte hard drive divided into a 10 megabyte partition to be used by the bridge board, and a 30 megabyte partition to be used for the Amiga. Once you determine the number of megabytes for each partition, and you know the number of cylinders on your hard disk, you can compute your partition sizes in cylinders with a simple formula. You simply divide the desired partition size in megabytes by the total hard disk capacity in megabytes, and multiply this figure by the hard disk size in cylinders. Thus, for a 10 megabyte partition on a 40 megabyte hard disk containing 613 cylinders, the size will be 153.25 cylinders. Since partitions must be defined by complete cylinders, round this up to 154. Another hard drive concept with which you must be familiar is interleave. Data is written to a hard disk in block size units, 1 block per sector. The interleave factor determines whether the sectors are handled sequentially, or whether after one sector is written, the controller skips one or more sectors before writing the next one. An interleave of 1 means no sectors are skipped, while an interleave of 3 means a sector is written, 2 are skipped, 1 is written, and so on. Since data is written in a checkerboard pattern all over the disk, there will be no loss of data capacity even if the interleave is greater than 1. The reason for the interleave is to compensate for slow hard drive controllers. Only the fastest controllers can access data that is stored with an interleave of 1. Access time, another measure of speed, should not be confused with interleave. Access time is the average time it takes the heads to position themselves at a given track. Once the heads are in position, interleave reflects the speed at which data can be read or written. Both values taken together are important indicators of overall speed. The last concept to be covered is formatting. Normally, there are 2 kinds of formatting: a low-level, so-called hard format done by programs supplied with the hard disk controller, and a soft format done by Amiga DOS with the format command. A third kind of formatting, applicable only to the Amiga, is rigid disk block preparation. A hard or low-level format prepares a hard disk to receive data. This type of format creates the tracks and sectors that will contain new data. As a result, it will completely destroy any data that is already on the hard disk. So, make sure that you are formatting the right disk. In most cases, it should be required only once when the initial partitions are set up. This type of formatting is basically the same for all hard disks, whether being formatted for the Amiga or for some other computer. The specific methods of rigid disk block preparation may vary, but this step is normally done after the low-level format and before the Amiga DOS format. Rigid disk blocks store the information that you would normally put in the mount list and allows the hard drive to be auto-mounted. The soft format, on the other hand, is done by Amiga DOS to prepare hard formatted tracks and sectors with the information necessary for Amiga DOS to read them. Also during this process, the first 2 blocks of any boot partition are loaded with the code that allows the Amiga to boot from that partition. Now that you understand these concepts, let's move on to configuring the controller board, which is equally as important as the hard drive in determining performance. This is the Great Valley Products' newest hard card. It can be configured with 2 megabytes of RAM in addition to a 40 or 80 megabyte quantum hard drive. The board comes from the factory with the drive already mounted as a hard card and all jumpers set to auto boot. If you don't have Kickstart 1.3, you need to disable the auto boot feature by removing the jumper at location J4. Also, since 2 megabytes of extra RAM are installed, the jumper at location J2 must be installed. With no extra RAM, it should be removed. Every SCSI device, including the controller, is known to the computer by an identifier between 0 and 7. Duplicate IDs will cause the computer to lock up. The GVP board has been hardwired to an ID of 7, which is the normal ID for a controller. The quantum drive, therefore, has its jumper set to give a different ID of 0. The EPROMs necessary for auto-booting are the large chips labeled odd and even at the top middle of the component side of the board. The drive gets its power from the 4-pin power cord soldered to the bottom right of the circuit board area. Pin 1 of the 50-pin data connector is at the bottom for both the board and the quantum drive. Also attached to the drive is a short pigtail for the LED hookup. The external SCSI connector is a standard 25-pin D-type, which will be accessible from the rear of the Amiga's case after installation. For the last device in a SCSI chain, terminating resistors are required. However, the GVP board is unusual in that none are needed for a drive mounted directly on the board. Since this drive has no resistors to remove, adding another device is as simple as plugging it in at the 25-pin connector. Even the GVP board, however, requires terminating resistors for the last device attached via this connector. The next board that we will look at, the Commodore A2091, is similar in many ways to the GVP board. It too can mount a hard drive on the board, as well as 2 megabytes of RAM. The first thing that strikes you about this latest SCSI board from Commodore is its clean, well-engineered design. Also, as you look closer, you see that all jumper pins are identified with meaningful labels, such as memory size, options, and LED. Let's take a closer look at these jumpers. First, observe the pins labeled memory size, which are used to tell the operating system how much memory is on the board. Down and to the left, near the rows of RAM sockets, you see the set of 3 pins to control auto booting. It comes from the factory with the 2 bottom pins jumpered, which enables auto boot. You must switch this jumper to the top 2 pins to disable auto boot. Very close to the memory size pins, slightly down and to the right, are the options pins. As they come from the factory, no pins are jumpered. If you have more than one device attached to your controller, then jumper the pins labeled 1. The second set of pins, labeled 2, need to be jumped if you have a hard drive that needs more time to respond to the boot signal from the computer. You will recognize this situation by a series of brief LED flashes as the hard drive is being read, but the Amiga does not boot. Try putting a jumper on pin 2 and check for a successful auto boot. If you still are unsuccessful, investigate other problems, such as improper setup. The last pair of pins, number 4, are reserved for future enhancements. To the right and up from the options pins, you will find the pins for the LED. it is best to wait until the card is seated before connecting the LED cable. Now we are ready to attach the hard drive to the board. The 50-pin connector has pin 1 at the bottom, so mount the ribbon cable with the red wire matched to pin 1. Next, connect either end of the power cable to the SCSI card socket. Then, attach both cables to the hard drive, taking care to match up pin 1 again. With all the connections made, position the board on top of the drive, with the 4 bolt holes aligned with the threaded holes in the bottom of the drive. Using the 4 screws that came with the drive, attach the controller card. Do not use the A2091's rubber shock-mounted bolts to attach the drive to the card. These are for mounting the hard drive on the 3.5-inch floppy bay shelf. Now you are ready to install your hard card. Before you do, however, make sure all power is removed from your Amiga system unit. Turn it off at the rear panel rocker switch and remove the power cord. Move to the front and disconnect keyboard, mouse, and joystick if installed. Finally, be sure to remove power cables and all peripheral cables from the rear. Remove the 2 screws from the bottom edge of each side, as well as the 5th screw at the top center of the back panel. Slowly slide the cover forward and remove it. Now the chassis is exposed and you have access to all bus slots and drive bays. While you're installing your hard drive, be careful not to drop or jar it in any way. It is a delicate mechanical device, and a mishap like this could ruin it. Now you can install your board either as a hard card or as a standalone controller. If you go with a hard card, you will normally use the rightmost slot, so that the thick hard drive will not overlap and prevent the use of an empty slot to its right. Remove the screw, then the spare metal bracket at the rear of the slot. Position the board vertically above this slot and begin to lower it in place. Be sure the front edge is between the plastic guides. Also be sure that the lower tang of the mounting bracket on the rear of the board slides behind the metal lip, directly below the rear edge of the motherboard. Once the board is at the bottom of the slot, with its connectors resting on the Amiga motherboard connector, you must apply gentle but firm pressure to seat the connectors. Sometimes a very slight rocking of the board up and down will help this process. Do not force the board. The board connectors should slide into the Amiga motherboard connector with only moderate pressure. When you think the board is seated properly, look at the top edge. It should be level or parallel with the motherboard surface. If it is not, it's probably not seated in the motherboard connector correctly. Reseat the board so that it is level. Now, with the screw that you saved previously, screw down the metal mounting bracket to the rear wall of the Amiga chassis. When installation of the hard drive is complete, connect the LED cable to the board. Your hard drive is now installed. However, if you have elected not to install your drive as a hard card, the next few minutes will show you how to install it as a standalone unit. The second 3.5-inch floppy bay is the recommended location for separate installation of your hard drive. First, disconnect the ribbon cable and power connector from DF0. Then, remove the 4 screws holding the floppy drive shelf in place. With the shelf removed, turn it upside down. Attach the hard drive to the shelf using 4 screws. The A2091 board comes with 4 very handy rubber shock mounting screws for this purpose. If you do not have these rubber mounts, then use some other type of non-conducting spacer, such as a stack of 3 or 4 washers, between the bottom of the hard drive and the shelf, so that the circuit board does not rest directly on the shelf. Put the shelf back in place and screw it down again, but don't tighten the screws just yet. Push the shelf all the way forward in its tracks. Slide the Amiga case on and all the way back. Now, push the exposed floppy drive back until its front face is flush with the cover face. Gently remove the cover once more, so you can fully tighten the shelf screws now that it is positioned correctly. Reconnect the power connector and ribbon cable to the floppy drive. The power connector for the hard drive will normally be larger than the one for the floppy, and it will be found on the other wiring harness coming from the power supply. Connect it now. Connect the 50-pin data cable to the hard drive, making sure that pin 1 on the hard drive is matched to the colored stripe on the ribbon cable. Connect the loose end of the ribbon cable and the LED connector to your controller, and insert the controller in the desired slot. Once this is done, you can replace the cover and screw it down, and you are ready to partition your hard drive. GVP's installation software emphasizes simplicity and ease of use, giving the user basic control over number and size of partitions. The default settings that the installation program generates are suitable for a wide range of applications and should satisfy a broad spectrum of Amiga owners. After clicking on the Install icon in the program's opening window, a text-based installation program starts up that asks you 3 basic questions. First, you must confirm that a GVP board is installed and the hard drive SCSI ID is 0. Next, you confirm that erasure of existing data is OK. The third question asks if you want 2 20-megabyte partitions for this 40-megabyte hard drive. If you take the default of 2 equal partitions, you answer yes, and you are done. However, in our case, we answered no, since we want 2 partitions. One 30 megabytes and one 10 megabytes. With these parameters, the program writes out data to the rigid disk blocks and copies over the workbench files. At this point, the partitioning is complete. Commodore's A2091 board has a partitioning mode nearly as simple as GVP's, especially if you have a quantum drive. In addition to this basic mode, however, the A2091 Setup software gives the advanced user a great deal of latitude in fine-tuning the hard disk for optimum performance. The A2091 installation program is based on the use of the mouse and requester boxes. From the initial window, you can go to another window that allows you to catalog multiple sets of hard drive parameters. This makes it very easy to configure several hard drives controlled by the same board. Another window allows you to control the basic features, such as partition size and boot priority. Beyond this, however, the advanced user has the capability of controlling partition location at the cylinder level, controlling the number of buffers, and even setting up a partition-unique file system for use by another operating system, such as Unix. Finally, you have the capability to locate and record any bad sectors that your hard drive may have. Upon exiting from the setup program, you can even check the extra RAM chips on the 2091 board for proper operation. The A2091 manual is complete and explains these operations in great detail. A careful reading of this manual will enable even the most inexperienced user to optimize the hard disk setup. Having formatted and partitioned your hard drive, you are now ready to organize it through the use of directories. A basic premise of good hard drive organization is to keep the root directory simple by minimizing the number of drawers. One technique is to create a drawer or directory for each category of software that you may have. For example, you may have several paint programs, so a drawer labeled Paint might be appropriate. Within that drawer, you may have two subdrawers labeled D-Paint 3 and Photon Paint. These subdrawers would contain that particular software. A similar example is word processing software. The high-level drawer might be labeled Words, and within it are other subdrawers such as ProWrite or Scribble. Using drawers to hold programs, you are still relying on the hierarchical or tree-structured directory system of Amiga DOS to keep the root directory clean. Whenever you open the hard disk window, you will be located in the root directory, as you see here. When you open the drawer labeled Paint, you move down to a subdirectory. From within Paint, if you open the drawer labeled D-Paint 3, you have moved down to a third level and are now in the D-Paint 3 directory. To explain the equivalence of Amiga DOS directories and Workbench drawers, look at the following CLI command. Here you see the root directory, the second level directory, and the third level directory. One important point that you should be aware of is that you only need and should only have one set of standard Workbench directories. Workbench directories such as C, Devs, Libs, among others, should only be in your root directory. A common error is to copy the complete contents of your application diskette to a drawer on your hard disk. In most cases, you will be making unnecessary duplicate copies of these system directories and wasting hard disk space. More information about application installation can be found on the utility diskette included with this video. Now that you have created your directories and installed your application software, you will certainly want to protect yourself from disasters such as a hard disk read-write error or worse. Reliable backups are your insurance policy, and there are 3 common techniques for backing up your application code and data. The first backup plan to consider is to load only your application programs onto your hard disk and keep your data on floppies. The second plan is to make complete backups at frequent intervals. And the third is to make what are known as archival backups, since they use the archive bit attached to each Amiga DOS file. Keeping programs on your hard disk and keeping data on floppies is a technique that makes users feel comfortable. The problem here is that your data access is at slow floppy drive speeds, and if you don't keep multiple copies of your floppies, you still don't have a reliable backup. Complete backups performed frequently, however, give you full protection with the least complexity. But it is time-consuming, and this encourages you to put it off. Murphy's Law guarantees that you will have a failure after you have procrastinated for the longest time. The third technique, archival backups, gives you the same protection of a full backup, but it takes much less time. A minor drawback to this type of backup is that you have to keep more than one set of diskettes for each backup. Several third-party backup utilities allow you to back up your files using the archive bit. A full description of these 3 techniques is somewhat lengthy, and we've provided you with full details in a README file on the utility diskette. It is important to remember to always have at least 2 sets of diskettes with which you alternate backups. Your single set of backup diskettes will be no good if you have a hard disk problem while you are backing it up, because both your hard disk and your backup diskettes are now corrupted. The golden rule of hard drives is to back up frequently on alternating sets of diskettes. Before we wind up our discussion of hard drives, we need to explain the hard drive sharing made possible by the bridge board. The Amiga contains 2 separate buses, or circuits, which carry signals and data. One is the Amiga's own bus that is linked to the CPU and other chips on the motherboard. The other is an IBM PC-compatible bus that is not connected to any chips at all. The bridge board is a clever piece of engineering by Commodore that bridges these 2 buses with a board containing a complete IBM PC. This board not only turns the Amiga into a PC-compatible machine, but it also allows peripherals on each bus to be shared between the Amiga and the bridge board. Hard drives are the most commonly shared peripherals. The Amiga can access a hard drive on the PC bus, and the bridgeboard PC can access a hard drive on the Amiga bus. Thus, a bridgeboard owner can share an Amiga hard drive and avoid the expense of a second drive. The exact method of sharing a hard drive depends upon which bus is involved. When the Amiga accesses a hard drive on the PC bus, it is given its own complete partition, which the PC can never access. This is known as a Janus drive. When the bridgeboard accesses an Amiga hard drive, it is not given sole access to a partition, but rather a reserved space within an Amiga partition. The partition is still controlled by the Amiga, and it can contain Amiga files as well as up to 4 bridgeboard spaces. Each space simulates one of the MS-DOS hard drives labeled C, D, E, or F. The recommended procedure, however, is to set aside one partition to contain only bridgeboard virtual drives and keep Amiga files out. In our previous examples, this is why the 10 megabyte partition was created. Before we discuss bridgeboard virtual drives, let's compare how the Amiga accesses a Janus drive. 3 commands are involved: A-disk, DP format, and DJ mount. A-disk is similar to the MS-DOS fdisk command, but it sets up a dedicated Amiga partition on the PC bus hard disk. But it is an Amiga partition, not an MS-DOS partition. DP format is the command that formats this hard disk partition for Amiga-DOS data. These 2 commands are used only at the initial hard disk partitioning and are not needed afterwards. The DJ mount command is used to mount the Janus drive whenever the Amiga needs to access it. There is no command to dismount the partition, thus it stays mounted until the next reboot. The opposite case, involving the access of an Amiga hard drive from the bridgeboard, uses 3 commands as well: mount, J-link, and the MS-DOS format command. The Amiga must first mount the partition before the bridgeboard can access it. A space of a fixed size, simulating an MS-DOS hard drive, is created within this partition using the J-link command. This is done with the /C switch. This virtual device is then formatted using the normal MS-DOS format command. After using the device, it must be unlinked using the J-link command a second time, but with the /U switch. This sequence of creation, format, and unlink is only done the first time that the virtual drive is set up. Any subsequent link to this device requires two uses of the J-link command. Once to link, but not create, since the virtual device was previously created with the /C switch. And once to unlink before turning off the machine or rebooting. If this is not done, unpredictable loss of data can result. For this reason, some users are apprehensive about sharing an Amiga hard drive with the bridge board. But with proper planning, this problem can be avoided. The explanation is simple. When you copy files to a virtual drive, a sort of high watermark is set at the maximum number of bytes used. The /U switch of the J-link command permanently records that high watermark, and all data below this mark is protected. To prevent the loss of data, you should set the high watermark at its maximum value by copying files into the space until it is full. Then, use the /U switch to unlink the virtual drive properly. The high watermark has now been permanently recorded at the virtual drive's maximum size. Now, you can delete and copy files safely, as long as you stay below this recorded high water mark. By following this rule, even if the Amiga is rebooted before an unlink, your data should be safe. Sharing drives in this manner can save the Amiga owner money and motherboard slots. It also makes it very easy to transfer data between the Amiga and the bridge board. One minor drawback is that data access and data transfer will be slightly slower when going through the bridge board. A second drawback is that auto-booting from a shared hard drive is not supported. For this reason, most users install an Amiga bus hard drive to auto-boot the Amiga and share this drive with the bridge board. Finally, a note on backups. Carefully read the specifications of any Amiga DOS backup utility you buy. Be sure that it will back up Janus drives, if you plan to use them. For J-linked virtual devices within an Amiga DOS partition, there should be no problem in using an Amiga DOS backup utility, since this space is treated just like any other Amiga DOS file. During this tape, we have presented you with a lot of information regarding hard drives for your Amiga series computer. You should now feel quite confident about purchasing, installing, or configuring a hard drive to fit your needs. Let's now review the highlights and important points made during this presentation. First, let's begin by reiterating our recommendations for configuring your Amiga. These recommendations should satisfy most of your needs and provide you with an optimum system. Auto-booting is a must. It saves you time. Remember, however, that to auto-boot from your hard drive, you will need a controller that will support it, as well as the 1.3 ROM chip installed on your motherboard. SCSI controllers are also well worth the investment. They allow you to add more hard drives or other peripherals in the future, such as CD-ROM drives. A 3.5-inch hard drive is the preferred drive, since it will not prevent bridgeboard owners from using the 5.25-inch bay. We also recommend that you buy or install a drive that is card-mounted. By doing so, it will free up another floppy bay. You should go for the biggest capacity hard drive you can afford. We recommend at least 40 megabytes in size. Many users doing graphics or video work should even consider 80 megabytes to be the minimum. Next, we discussed partitioning your hard drive. This, as you remember, is used to segregate and organize your data. The concept of sectors, tracks, and cylinders was fundamental in understanding the partitioning process, and you should review this part of the instruction if it is still confusing. The 3 steps in partitioning you will recall are: perform a low-level format to establish the cylinder and track structure, define the rigid disk blocks to store the parameters for auto-configuring, and finally, initiate a high-level format using Amiga DOS. To logically organize your data within a partition, you should create drawers or directories that you can utilize to suit your particular needs. Remember that the single most important guideline is to keep the root directory uncluttered by having only drawers or directories in it whenever possible. Programs and data should generally be stored below the first level of directories. And finally, remember our warning about copying entire program diskettes into a drawer. You should copy only the programs needed. You should not copy multiple versions of the Amiga DOS system directories, such as C, devs, libs, or others, into these drawers. If you find that you have too many subdirectories, this may indicate the need for another partition. But remember, too many partitions will use up more and more of your precious chip RAM. The GVP and Commodore boards seen in this tape represent the state-of-the-art for SCSI hard cards. If you have either of these, you should now feel confident in your ability to set it up and install it properly. Even if you own another brand of controller, the principles learned in this tape will be the same. Bridgeboard operation, which enables the sharing of hard drives, can be confusing. It is important for Bridgeboard owners to remember that there is a fundamental difference in the way a PC or Amiga hard drive is shared. A PC hard disk can have one or more Janus partitions dedicated to the Amiga, which are inaccessible by the Bridgeboard. Any Amiga hard disk, however, can have up to 4 MS-DOS virtual devices. These are not partitions, but are a special type of Amiga DOS file within an Amiga partition. These subtle differences are important to remember when following our recommendation to put all MS-DOS virtual devices in one Amiga partition. This will guarantee a certain level of data protection by segregation. A separate partition for Bridgeboard data may also reduce your backup time. By doing this, you will only need to back up this data when it is modified. This will generally be less often than Amiga DOS files. A file backup method and philosophy that is religiously followed cannot be overemphasized. We recommend the archival method, since this is proven to be the best all-round method for us. Full backups may be the simplest, but take the longest time. Don't rely on the method of keeping your programs on your hard drive and data on floppies. This defeats the purpose of a hard drive and is not really a suitable backup method. But no matter what method you choose, back up your data frequently. And for further information on these topics, don't forget to review the files on the utility diskette supplied with this tape. We hope that the material in this tape has been of help and that your understanding of Amiga hard drives will assist you in making more knowledgeable decisions about buying, installing, and using your hard drive more effectively. So from all of us at Telegraphics International, thanks for watching, and best of luck with all your computer efforts.